Hello, this is David Green. We're going to be talking now about collections. This is in your text for the EE333 students in Chapter 12 with some pretty advanced concepts in Chapter 20. You may wish to read Chapter 12 in order to get a background on the material that we're talking about here. Read that material to focus on the concepts that the author is going through and not the extreme details of his code, as it refers to his NHUtilities package instead of the Java distributed packages that we'll use in this presentation. For this presentation, we're going to use the what is called the Java Collections Framework. This was released in Java version 5 or 1.5 of the JDK. This collections framework is in the java.util package, and as you can see from the java.util package, there are a number of collections: abstract collection, abstract list, abstract map, and so forth, as well as other things that aren't related to collections, but the linked hash maps and things such as that are related to collections, as are the queues. So there's several things in here, and there are also interfaces and exceptions that come from this effort. We're going to narrow our focus for the present purpose of this presentation down to basically ArrayList, which we have on the screen here. So the author uses the word containers instead of collections, and I think those are fine to use interchangeably. The collection in Java will be modeled, as you might guess, as an object. And in this case, a container or collection is an object whose purpose is to contain other objects. So this is our formal modeling of data structures of containment. Our particular focus right now is on objects that are of all the same type, so that inside of our array list we'll have objects that all belong to the same class that we mentioned to be the collection that we're making. Now, through the use of superclasses and special chosen interfaces, we still have a lot of flexibility in exactly how we do it, but in the end we'll have to point to some class or interface as being our collection point, and all the objects in the array list will have to conform. We are looking right now at the Java doc for ArrayList, and we'll come back to this periodically, but I do want to look at some code here in a minute as well. For the moment, notice that we have ArrayList, and it belongs to a hierarchy of classes. There's an abstract collection, an abstract list, and then finally an array list. And if we were to go up to the abstract list, we'd find a number of classes underneath of it. And if we look below array list, we find several classes beneath it that are also implementing this concept, as well as a collection of interfaces that are related. We won't go into those right now. Now, the unusual thing, if you've looked at these class definitions before, is this angle E angle that occurs here. The in Java 1.5, this concept of generics was created that allowed us to talk about a class that implemented an algorithm. In this case, our algorithm is essentially an array algorithm, and we're allowed to specify as a parameter when we create an object what the type of the contents of that array are. So in our particular case, this would be the type of things for an array. Of course, if you were building a generic base class for something else, you could send in other parameters for other purposes. But in our case, this allows us to package an item that takes a type, write the algorithm somewhat generically, like abstract data types were done in C, only instead of using fancy includes, we use the new generics capability of Java to accomplish our action. And with that, get strong typing so that the compiler diagnoses things, and only write our algorithm at most once. Of course, since ArrayList is already written by Sun/Oracle, we don't have to write it at all. We just have to learn how to use it, which will be principally what we do in this example. And as we'll find out as we go, a capability of the ArrayList is to automatically grow and shrink in size as our needs arise, rather than be bound to a fixed size for the life of the program. So with that, let us move to the program in NetBeans. And this has got some Java comments, as is typical for our coding, but I'm going to collapse those for the moment so that we've got more of our algorithm, or our demonstration rather, on the screen. So since the ArrayList itself is inside of a package that's not Java lang, we have to import either the class or the whole package. I've chosen just to import the class, so here we have our import Java util.ArrayList to import that class, so it's now known to the compiler. And then I have chosen to package up my program into a class called Simple Collection Demo. And I'm going to follow sort of the idea of making an object of this type, my program object, and then executing code inside that program object for the demo. So that allows me to have some instance variables of ArrayList string. So see now that I'm going to have an array list of strings. So the way I code that is I put angle string angle as the type, and I create the variable strings to be my reference variable to that array list. And I guess to conform with our usual good coding, we'll make that a private instance variable. Now in a similar manner, and I'll copy in private right here now too, in a similar manner, I might wish to have an array list of ints. Unfortunately, the way generics work is the thing that is specified has to be an object. We have to be able to do the refer capability to it. Fortunately, for every primitive like int, double, float, etc., there is an object or an object type such as capital I integer, capital D or capital F float, and so forth, that are object wrappers for those primitive data types. And so in this case, I'm going to have private array list angle integer angle integers. So I've just used the word strings and integers to remind me, hopefully in a self-documenting way, what the array list is all about. So those are my instance variables for my program. Here is my main for the program. And what I'm going to do is I'm going to make a demo object of type Simple Collection Demo, which is the name of this class. New Simple Collection Demo. So I now have an object of that type, my program, and then I'm going to say demo.run. Hopefully I've written both a constructor and a run method so that these occur. And I really don't need to add any more program logic, so we'll get rid of the to-do statement there as well. Okay, so here is the constructor for a simple collection demo, and what it is going to do is it is going to make a array list so that my instance variable is referring to an actual item. See up here I just declared the variable, very similar to what we've done time and time again. And here I'm going to say new array list angle bracket string. So now the class name has been expanded, if you will, to include the generic or the type that I want to make the array list of. And then the open paren, close paren in order to invoke the default constructor for the array list string. And that is written by the folks that wrote ArrayList, so I just have to call that constructor. I don't actually have to write it. And I'll write a similar one for my integers. And that ends my constructor. So now that everything is ready, we've made our object, we ought to be able to call run, and here is my run to run my simple example of using these two array lists. Hopefully, to reduce confusion, I'm going to work with strings first and come back and then deal with integers on the sort of a second pass, so we can see how they are extremely similar, and notice one sort of gotcha, if you will, relative to generics. So I have chosen to write a function called populate, which I'll feed my strings to. And strings, of course, is array list angle string. And the job of that, as we see down here, is to, we're right in here, we're to receive and populate an array list of string, which I'll call AL down inside this method. So that array list, which we just made, so it has no items in it, is sent down to this routine, and we will populate it. We're just going to run a little loop here for I equals 0, I less than 5, I plus plus. So we'll run 0, 1, 2, 3, 4. And what we're going to do is we're going to create a string. So we're going to do string concatenation. And we're going to take the text string number space and I, and since I is an int, and we have a string over on the left side, the plus will be associated with strings, and I will be converted to a string, and so the first one will be called string number 1, then string number 0, string number 1, string number 2, string number 3, string number 4, and we're going to call the add method of ArrayList. So let's go back to the Java doc, and we'll scroll down a little bit, and we see there are two add methods. One add method says it takes an integer and this. That's not ours. We were doing add of just a string, so that must be this one. So you see E the class, E the data, and this says appends the specified element to the end of this list. So if you recall, strings was array list string. So E, the E that's up here, for me is string at the moment. So we're going to add a string. We'll get a Boolean, and if we look at the details of this, we're going to append the specified element to the end of this list. This is some stuff on where it's done, where other code related to this is, and we're going to get a true back at all times. So it's always going to work. We're always going to be able to add one, which, you know, behind the scenes mean this is that this array collection can continue to store items until we run out of space in the memory of the computer. So going back now to NetBeans, we should populate our array list string and return it. So we were here, so now we should be here. Print strings create strings. So this is going to call a print function that I have down at the bottom of the code listing. It's going to feed in my array list. It's going to feed in a string here that I'm going to use sort of as a tag. So let's go down and look at that. So here's the print routine. It's going to take in an array list. Notice I have not put angle brackets here. I'm going to use I'm going to print both all types of array list, or at least that's my goal with this. Here's the label coming in, and I'm going to do system.out.println the label plus a colon, a space, and then I'm going to print the array list, and I'm counting on array list having, like all other things do, a toString method that'll work for me. So whatever it gives me as a toString, I'm going to slap a label, a colon, space in front of it, print it out. And what we're going to do now, I think, is just run our program here and look at the first time we get an output. And look at that. So here is the create string. So you see the label that came down. You see an open square bracket, string number 0, string number 1, string number 2, string number 3, string number 4, close square bracket. So what's happened here is from the open square bracket to the close square bracket, the listing of the contents of the array list with the commas in the middle are all part of the toString of ArrayList. And we go back to our Java doc, and we look here. We're going to look for toString, toArray. So there's no toString here. So we go to methods inherited, and it's not here, and here, here. So it's part of abstract collection. So here's the toString that we're actually running. String, and say returns a string representation of this collection, and it calls out the formatting. So this thing documents, and you can see that we're inheriting this behavior from one of the classes up above, the abstract or above our array list. So here we are back in our array list, and you can see that abstract collection's up here, and that's where that method is that we're using. Okay, so back to the code. So we can sort of see that we populated it, and our string objects are inside the array list called strings. Now we're gonna just play with a couple of the other methods of ArrayList. The first one we're going to play with is the remove method. And if we go to the Java doc and look at the remove method, we'll find there are two of them. There is a remove that takes an integer, which removes the element at the specified position in the list, and then one that removes the first occurrence of the specified element from the list if it is present. Well, 3 is obviously the thing that matches this int. So going back. So we're going to take the fourth item, 0, 1, 2, 3. We're going to remove the item at position 3, 0, 1, 2, 3 in the string. And so we go look at the string, 0, 1, 2, 3. That's the one we'll expect to disappear. Is the one at position 3, so string 3. And here we remove it with any luck at all. And here we're going to print things out with a little label that says we removed the one at position 3. So we've already run this, so let's just look at the output here. Removed the one at position 3, 0, 1, 2, 4. So sure enough, the one at position 3 has been removed. And note that there is no hole. We have removed the item from the collection, and now the collection is one smaller, and everything's been packed back in. So that's something that our array didn't do, but we've often written code in order to make that happen. This is just the behavior of the array list. Carrying on with the example, now that we've done this remove, we'll move on to the next item, and here we're going to remove an object. Okay, and if we look at this remove, this takes an object, and certainly a string is an object. And going back to the documentation again, remove an object, so we'll read this, removes the first occurrence of the specified element from the list if it is present. If it does not contain it, it is unchanged. So what it's going to do is it's going to start at the beginning. It's going to find the first time there is an object that is equal. See that it actually tells us it's going to use the equals method to decide whether the two objects are the same. So it's not going to use identity, it's going to use the object's equal method. And we know, going back to our code, that the definition for the equals method for strings are the strings have the same characters. So I've been very careful here in the one I'm removing to type string number 1, which matches the text of a particular string. So here's string number 1, for example. So I've got the text exactly right. So when I do that remove and then print, here's remove string 1 colon string number 0, string number 2, string number 4. So you see that it was found and removed. And that's a quick demonstration of using an array list for strings. Let's come back now and work on the array list of integers. So as you saw, we already created the reference variable for the array list, and then instantiated. So we created the reference variable up here. We created an instance of the array list integer here, and now we wish to populate it. Okay, so let's uncomment here, and we get a little red sign there. I wonder what that's all about. Let's see what it says. It says one of them is Java lang string and one of them is Java lang integer, and you haven't written both. Okay, well, that's fine. Let's go down here. Here I have commented out one that I've written, so let me, okay, so notice here, this one's populate array list string, this one's populate array list integer. So I'll come along here. I think I've looked up that this is the keystroke to toggle comments, and oh my goodness, more errors. So if I read the errors here, it says there's a clash. The populate with a string and the populate with an integer have the same erasure. Well, what that says is that the generics types are not distinguishable with parameter passing. So the Java tool here is telling us that as far as it's concerned, those things are saying the same thing, and I can't figure out which one's which. So I'm declaring them to be clashing. And this falls, and your author talks about this more, this falls back to the fact that generics were sort of an add-on to the basic facilities that were already in Java that didn't have this. And in order to avoid making lots of things that would make people who'd already written code in Java rewrite things, they made some things, made some concessions, and we've now hit one. So what I'm going to have to do is essentially change the two populate functions, and I'm just going to call the second one here populate integers, and then I'll call the one up here populate integers that uses it. And with that, all the little red things go away. So that's, just wanted to point that out as a slight problem with using these. When you pass them as parameters, there are a few things you have to do a little bit special. Okay, so I've done that, and let me just go on and uncomment all these places here. If I'm lucky, we won't have any more errors. I really uncomment everything, straighten things up, and we'll hit a save to check that, and we look across here, we don't see any errors. So let's go back and look at code. So now we're going to populate the integers. And if we go look at populate integers, it's going to be fed the ArrayList integer. We'll call it AL. And we're going to say for I equals 0, I less than 10, but this time we'll increment I by 2, so we'll still have 5 of them, but we'll only use every other one. And what we're populating is objects called integer. What our loop is doing is the primitive int. So I have to make a new object type integer, feeding it the loop index each time in order to add them in. So a little extra work to deal with the primitives, but it makes the ArrayList framework all available to me without me having to write the framework. So I'm happy. So I've done that work. Come along now and print out the integers with a similar set of words to what we used before. In this case, the create integers. And if we go remind ourselves of the print, it takes an array list, and notice we didn't use the angle anything here. So we know that Java can't tell them apart, and we don't need any typing. The only thing we're relying down here is on the toString, which everybody has. So we're kind of good to go with one print. So let's run it and see what happens, and see if our populate works fine. And so here's the create strings, here's the create integers, 0, 2, 4, 6, 8. Okay, so that's our 5 integers. Let's go up and look at the rest of the methods here. And here we're going to remove the second integer, 0, 1, 2, and if we look at our integers 0, 1, 2, we should remove the value 4. So when we look at the print here, removed at position 2, 0, 2, 6, 8. Yeah, so 4 is gone. We've noticed the collapsing down, so this works just like the one above did. Now in this next case, I want to remove a particular integer, so I'm going to need to make an integer. I'm going to pick 3. Now you know we're dealing with even numbers only, so I don't think that's really there. So we'll say new integer 3. So we'll change our int 3 into the object integer. Call remove, and then print out remove 3. And then down here under remove 3, we see 0, 2, 6, 8. We have the same number we had before we ran that method, because 3 wasn't there to remove. So maybe we should actually remove something that's there. So let's change the 3 to say an 8. In the print statement, let's change it in this constructor where we're going to make our item. Let's save it, run it again. And now when we remove the 8, 0, 2, 6, you notice the 8 is gone. So we've used the remove object correctly for an array list of the list that we have. So this has been a quick look at ArrayList. We could spend a minute here looking at the other methods of ArrayList. So we've noticed that there's an ability to add things. There's an ability to add a lot of things at once, add all of particular collections. There's an ability to clear them all out at once. We'll come back to clone in a minute. There's an ability to ask, is a particular item inside our container? There is ensure capacity. We'll come back to that. There is go get one. So unlike remove, what the get method does is it gets us access to that object without removing it from the collection. There's also index of, which finds the first time that object occurred. In case we had two strings that were in there that were the same, if we wanted to find the first one, we'd do index of. If we wanted to find the one on the end, we'd do last index of. There's also a method called isEmpty, which I think does something rather predictable. There's the ability to remove a whole range of numbers from one index, or items rather, from one index to another. There's an ability to set. So rather than add, which would increase the number of items in the collection, set would overwrite a particular one. There's an ability to ask how many are there in there at the moment, size. There's an ability to get out an array in a couple forms so that you get a real Java style array instead of an object, should that be necessary to work with other code. And then trim size. So we've kind of left a couple here for finishing up. So let's take the sizing ones first. So let's hit trim size here. I think they're all kind of, these two are close together. So what trim size does, or rather, let me back up and say what Java does is it allocates space as it needs to. So if you have been doing some adds and it has to allocate some more space, you do some removes, it doesn't usually give that space back. You do some more adds, it'll use them, and it'll do its internal management. You could, of course, end up with a lot of unused memory, and if you were optimizing, you might want to give it back. So trim to size is a method that allows us to trim this concept of how many we could store in there, which they use the word capacity for. They use the word size for how many are in there, and capacity for how many could be stored in there with the present memory allocation. So this would trim the capacity back to the current size. Likewise, if you knew you were going to add a whole lot of items over the next short bit of time, but doing it incrementally, I add one, add another, or something, and you didn't want the resizing or the recapacitizing, if you would, of this array collection to be done over and over and over again every time you added one or so. You could ask to ensure the capacity of the collection to be some minimum size, and this would be your way to hint to the object, the container object, that it needs to allocate a whole lot of space, and you'll know you'll use it here coming up shortly. So both of these sort of categorize themselves as optimizations, if you will. They either look at the memory footprint or they look at performance. The other one I held back on, I think, was clone. Let's see if we can find that here. So clone returns a shallow copy of this ArrayList instance. The elements themselves are not copied. So it returns a copy of ArrayList, and you would do this because you are handing it to somebody, or you're handing a reference of it to somebody, and you don't want them to mess with your original collection. Now, when you go do a copy of objects which contain objects which contain objects which contain objects, and this could go on quite a long time in a Java modeled or an object modeled environment. It's not a Java only problem. You get into a situation to decide, what does copy mean? When you go to copy an array list, since the items that are actually in the cells of the array list are not objects but references to objects, do you copy the references, in which case you have multiple references or multiple pointers to the same object, the same string or whatever? Or do you also make a copy of the object that's being pointed to or referred to? Of course, if you make all those copies, it takes a long time. If you just make the copy of the references and have the those things done just at this high level, it's faster. But if people are going to go and modify the objects, you might want to actually that might be a bother to you, and you might want them copied as well. So it's in the programmer and the application developer's hands to decide what's the right thing to do. Here we're just being told what the clone method for ArrayList does, which means if we wanted more than that, we have to do it on our own. And the word shallow copy means that we'll only do the top level copying of the object, and we'll just copy the references. We won't duplicate the objects. So that's what that's called. And if you came upon a method that turned out to actually duplicate the elements or the objects inside as well, then that'd be called a deep copy. But again, that's not what's being done here. Okay, so this has been a quick look at ArrayList, and these are a relatively new part of Java. You'll find them referred to as part of the Java Collections Framework. We learned a little bit about generics, which allow us to handle concepts associated with data structures, where we want a kind of collection operation independent of type, but where we want the enforcement of type for error handling on an actual instantiation. In other words, we want to be able to specify something like an array or a linked list. That would be another one of these classes. And we want to control the type, but we don't want to write the code, underlying code each time. We want the power of the abstract data type. You can see that with typing, we'd like to be able to continue to use our inheritance power and our interfaces so that we can collect these classes as appropriate. And as mentioned a couple times, there are many other classes here, so if you need a different type of behavior than an array, shop around. It's probably been built.